On this video, we're going to see how to model a situation using regression analysis on Desmos. Let's assume here we're given a problem. And that problem contains a table with a relation between time and a certain amount. So the first thing in order to model this situation is to get this table on Desmos. One way of doing that is to go to Desmos, click on Add Item, and then Table, and start typing one value at a time. If you already have the table on a spreadsheet, you can just copy and paste it. And you'll get both the table and this one right here on the right is called a scatter plot. The next step would be to find the model. But before we do that, we're going to start filling up our presentation. So on the first slide, you're going to type your names and student IDs. Then you're asked to write down the problem and the table. So I'm just going to copy and paste the problem and the table as well. So this is to provide some context on the situation. So once I have that, the next step is to insert an image of the scatter plot. We already have it over here. You just have to click on Share Graph, Export Image. I'm going to select large rectangle with thick lines, and I'm going to copy and paste it. Once I have the scatter plot, I'm asked to find a model using regression analysis and to insert both the function and the graph. So let's start to do that. The model that we're going to use is one that looks like this. Y is equal to C times E raised to the power. So in order to write the exponent, I'm going to select this option, raised to the power of kx. So on this particular case, I already selected the base, the natural exponential. And I'm just trying to find what k and c would be in order to fit this function into the data that we're providing. But one thing that you have to realize is that the name of the variables on the table, the labels are x1 and y1. So I have to use the same variables on my function. So I'm going to start by turning y into y1. And in order to do that, I'm going to click on ABC. And I'm going to select this button to insert the subindex. So now I have y1. I'm going to do the same thing to x. I have to make sure that I'm on the exponent. And then I'm going to select x1. And suddenly I have lost everything. I have lost every value on my table. I have lost my scatter plot. That is because those values might not belong to a perfect exponential. And if I write an equal sign here, I'm looking for a perfect exponential. So I might have to lose the equal sign. And I have to settle for an approximation. In order to do that, I'm going to select this option right here. And now this is an approximation. And I have my parameters, and I can actually write my function based on the values that I got there. So I'm going to do that. I'm going to write f of x is equal to, now I have my c value as 7.83064. The base, I had already selected a natural exponential. And then I have the k value, the rate. So I'm going to write it as 0.284322. I'm going to use every decimal I'm giving here on Desmos, and then I need to write down my variable. In this case, it's time, but because we're talking about Desmos and the Cartesian plane, we need to use x and y, or f of x and x. So this is my function. This function was provided by Desmos using regression analysis. How do I know if this is reliable? Well, if I look at it, it looks like it's very close to every coordinate provided that I provided on the table. Another way is to look at this r-squared value. That means that the closer this value is to 1, or actually if the value is equal to exactly 1, it means that my model is hitting exactly every coordinate. So it is a perfect exponential. In this case, I'm very close the average distance between the dots, the coordinates, and my model is very small. The closer this value is to 1, the more reliable the model is. The closer that value is to 0, it means that the variance is very high and the model and the data is too far away from each other. So in this case, it looks like we have a reliable model, and we're going to insert our function, but not a screenshot of this, because I would have to ask people to put the function together. I have to provide the actual function. I already have that over here, so I'm just gonna copy and paste the image, but you can write it down, but not a screenshot of this, because this is not the function. It is a broken function, and I have to put the pieces together. So now I have my function. What's next? I need a graph, an image of the graph. So once again, I'm going to go to share graph, export image. I'm going to select large rectangle with thick lines, and I'm going to copy the image. One thing that you need to consider is that you're not going to hit every point. It's very hard to find a model that passes through every point, but I'm looking for something that's close enough to every coordinate. If you notice, the values, the dots, the coordinates at the bottom are not a perfect fit, but they're very close. And that's why we get the 0.98 over here, because we're very close to the coordinates. The distance between our model and the coordinates is too small. So now that I have both the function and the graph, I need to insert the URL of my graph. Before I do anything else, I have to make sure that I save my work. So make sure that you log in, that you save your work to be on the safe side. And then I'm not gonna copy this link on top. I have to go to share, and then I'm gonna share this link. I'm gonna copy and paste it. Not the one on top, but the one provided by this. So I'm gonna just copy and paste this one. And the last step is to answer the question that you're gonna be given on every model and to write the solution over here. So on every model, you're gonna be asked to find a prediction, a value that is not actually on the table. In this case, we're asked to find what happens on time 12. So 12 is not on our table, but because now we have a model, we can actually predict any value that we want. So X is the time and Y is the amount. So if I want to know what happens at time 12, I just have to go to 12. So 12 is right there. And I'm getting 237.437. So I'm gonna write it down. 237 point, I believe it was 437. And this is a value, and on the problems that you're gonna be solving, you're gonna be required to write the units, but then a conclusion. What is the meaning of this value? You need to reflect on what does that mean, and you have to write a paragraph that states that. So that is basically what you have to do. And once you have the solution and the reflection, the conclusion, you are going to do a self-evaluation and a co-evaluation, and you would have to submit everything individually.